What's going on, guys? In today's video, we'll be learning how to use Open PGP, pretty good privacy, for encrypting emails or messages and sending them encrypted between two different recipients using each other's public key. So how this works is you send your public key to someone, they send you theirs, and you use each other's keys for signing and encrypting messages between each other. So once you generate a key using GPG on your device, it stores your secret key and the public key that you could use to send to whoever you want. So let's go ahead and generate two different keys for this example and walk through. One on my local device and another one on a Raspberry Pi. So you're going to have to run gpg -- full key generate. It already sets ECC for the default encryption. Curve is fine. If you want the key to expire, you could set it right here. But for this example, we're not. Set your name. You could add an email address. So adrian@example.com. You could add some comments. Okay, now it's going to ask for a password. Hello world, 123. Hello world, 123. Okay. It generated the key. Now we're going to want to export the public key so we could send to the Raspberry Pi or my recipient. So gpg -- armor export adrian@example \sign my key dot, save it into a file called mykey.asc. It's exported it into this file. As you can see, that's Adrian's public key. Or let's rename it. So, oh, you know what? Okay, well, yeah, let's rename it. Oh, never mind. That doesn't matter. I could just copy the text. Okay, now on the Raspberry Pi, generate the key. Full key generate. Oh, shit. Full generate key. My bad. All right, ECC by default. Curve 0. Yes. Full name Sam. Sam@example.com. No comments. Capital O. Password Sam123. It's not a secure password, I know. It's an example password. All right. Export the recipient's key. gpg -- armor. What was the command again? -- armor -- export Sam@example. It's not correct here. My key.asc. Okay. And there's Sam's public key. Whoops. Okay. Now we could just copy the whole public key. And let's say we've already sent the clear text for the public key to Sam. So I'm going to just copy it over here. Nano Sam key.asc. It's the old one I made. Okay, so that's the new one. Save it. Now we're going to copy Adrian's public key. And let's say we've sent it to Sam already. That's Adrian's key, like so. And that's now each recipient has the key. So all they have to do now is import each other's public key into their system, in order to send the encrypted message. So all they have to do is run gpg -- import Adrian key, gpg -- list keys. It's gone ahead and imported Adrian's key, as you can see right here, Adrian, and this is the primary user, Sam. Now let's go ahead and do that. Import Sam's key into Adrian. And just like that, we've imported the file. Now let's send an encrypted message to each other. So I usually like to just send a txt file, like so, nano. So here's where we could write a message. You could send it in the actual command as well. You don't have to make a file, but why the hell not? So in the file, let's say, hello, Sam. How are you? All right. That's the clear text file. How do we encrypt this? All we have to do is run gpg -- encrypt. I already have the command right here. -- encrypt -- armor. You have to set your recipient -- recipient. We're sending it to Sam, sam@example.com, and the txt file you want to encrypt. So the readme.txt. Enter. Use the key anyway. Yes. And now it's created a readme.txt with the ending with ASC. And that's the encrypted message instead of just sending the clear text file. So only Sam could decrypt this message no matter if there's an interception between the email or any sort of protocol you're using. Now all we have to do is send this to Sam. You could just copy this and paste it into a file for Sam. Or for this example, let's say we've sent it already through email and Sam has the file. Let me just go ahead and put the file in the Raspberry Pi. Okay. So now Sam has the file I sent him, which is encrypted using his public key. That's the message he receives. If someone else receives this message, they can't decrypt it because only Sam has the secret key in his device. All he has to do is now just run gpg -- decrypt decrypt readme.txt.asc. It's going to ask for Sam's password, like so. And there you go. That's the decrypted text file on Sam's computer, which only Sam could see. Now let's, for the hell of it, let's just send Adrian a secret message. So all we have to do is, let's make a file. Like so. Let's send him another text. Simple message. Clear text. It's there. What is it with H verification nowadays? Now we encrypt the file, GPG, encrypt, --armor, --recipient, Adrian at example.com, example.com, and the file, which is hello, yes, cat hello.asc. That's the encrypted file, the encrypted message we're going to send to Adrian. Now we can just copy this text. And so I don't want to SFTP into the actual computer. Paste the message there, like so. So Sam has the file. Oh, not Sam. So Adrian now has the file. All he has to do is decrypt it, asks for Adrian's password, hello world, 123, and there you have it. Adrian received the encrypted file and was able to decrypt it successfully. What is it with age verification nowadays? And yeah, that's pretty much how it works. It seems confusing at first, but once you get used to the commands, it becomes second nature. So this helps by keeping your privacy secure. Also helps with good OPSEC and hides your data from big corporate, big tech. It's basically sending messages securely like we used to before, without all the spying. Yeah. That's pretty much it for today's tutorial. I might bang out another video today for setting up a XMPP server, so stay tuned for that one. And yeah, have a nice day. Take it easy.